Hey all, happy day after the 4th of July. Hopefully you had a fantastic evening. Today is part 2 of our fun facts for this weekend, and I think you're going to like this one. It's pretty mind-boggling, but before we get to that, we're going to build our foundation of understanding within the world of mathematics, and we're specifically going to talk about something called factorials. Factorials allow us to calculate the different combinations or outcomes of an event. And knowing that is going to help us as we get into our fun fact. So let's talk about factorials. All right, so the factorial formula is represented by n followed by an exclamation point. And what this really tells us is that we multiply the number represented as n by all of the subsequent numbers until we reach the number 1. So let's take a look at this a little bit more in depth. Factorial 1 is 1 times 1, which equals 1. Factorial 2 is 2 times 1, which equals 2. Factorial 3 is 3 times 2 times 1, which equals 6. Factorial 4 is 4 times 3 times 2 times 1, which equals 24. So if we wanted to use an example to highlight factorials before we jump into our fun fact, and we say we want to know the different combinations of seating for 4 individuals, we would then just multiply 4 times 3 times 2 times 1, which equals 24. So there are 24 different seating combinations for those 4 individuals. We now know how to calculate factorial. What I would like to show you now is just how much of an increase there is between 4 and the subsequent numbers. So you can see between 4 and 5 the difference between 5 and 6, and that these numbers continue to grow exponentially. And yep, you guessed it, from 6 to even 7 is a huge difference. So keep this in mind as we begin jumping into our fun fact. So let us jump into our fun fact. We now know about factorials. You probably all have experienced and played with a deck of cards before too, right? Specifically around shuffling. So our fun fact today is the different combinations of a deck of cards. Now to find the different combinations that are available, we use factorial, which would be, in this instance, 52 times 51 times 50 times 49 times 48 times 47, so on, all the way down until we get to the number 1. We plug that into a calculator and we get this. And no, this is not an error on your calculator. This shows that the number of combinations of a shuffled deck of cards equals 8.7 times 10 to the 67th power. This is roughly 8 followed by 67 zeros. So that's a massive number, but just how massive is it? Let's put it into perspective a little bit. If we decided that we wanted to write a new permutation of these cards or a combination of cards, or simply if we shuffled cards every second and we went back 13.8 billion years, we'd still be coming up with new combinations of the way cards could be shuffled today, and we wouldn't have repeated ourselves. And actually, we'd probably be coming up with new combinations for millions of years into the future. When you think about that, that's before these guys were roaming the earth, and we'll be writing new combinations of ways to shuffle cards long after we're gone. So why do I like this fun fact? Well, one, it's crazy that we could shuffle cards once every second and not be able to find all of the different patterns for 13 plus billion years. But it's also pretty cool because the next time you're shuffling cards, when you come up with that shuffle, you may have created something that the world has never seen before, and that the world may never see again. It's pretty cool. Have a great week.